Alright, welcome back to Lesson 11. This is part 3 of Administering Windows 7. And in the last two segments we talked a lot about troubleshooting. We talked about developing a troubleshooting procedure that would work for you in just about any kind of troubleshooting instance with Windows 7 and other operating system errors. And we also talked about some tools that we've talked about in the past for helping you troubleshoot those issues. Then we talked a little bit about remote access and how remote access can help you troubleshoot issues on other users' computers even if you're not with them. Today we're going to talk a little bit about troubleshooting, installation, and startup issues and how difficult they can be. 9 times out of 10 you're going to be in an environment where at some point you're going to be troubleshooting some of these startup issues, so it's only fair that we go over some of the ways you can do that as well as how the troubleshooting process works. Alright, well, first thing you need to understand is that a lot of the Windows XP components have been removed or changed during the Windows 7 operating system. So a case in point would be, well, first of all, look at the table in 11-2 on page 418. And I'm not going to go through everything on this table, simply due to the time constraints of this lecture. But I will say that this table is very important. It's important to understand that these 4 basic elements of the Windows XP components have been replaced by different components in Windows 7. For instance, the NT loader has been replaced by the Windows Boot Manager and the Windows Bootloader, and so on and so forth. In Windows 7 now, there are basically 6 startup steps involved in the startup process for your system, and we'll go through those in some detail. So let's begin with the very first part of how Windows 7 boots up, and that would be with the post phase, or the power on self-test. Now the power on self-test begins when you first turn on the computer and it loads the BIOS or the extensible firmware interface, or EFI, into memory, and it runs the hardware self-test procedure. Very simple, seems like. It's basically primarily a hardware function of the system. Next is the initial startup phase. Now on BIOS equipped computers, this means reading the BIOS settings to determine which hardware devices it should use to boot the computer. Now when it's booting from the hard disk, the system is going to load that master boot record from the disk, and it will then locate which is the active partition of that drive. Next we have the Windows Boot Manager phase. And here the Boot Manager actually reads the boot configuration data file, or BCD, which contains the system's boot menu information, and then it will provide the user with access to the boot menu. This is particularly important if you have more than one operating system on your computer. If you don't have more than one operating system on the computer, the boot menu only appears when the user presses the key just after the post, which is the F8 key. Next we have the Windows Bootloader phase. Now the system initiates the memory paging process at this level and then loads the various operating system elements into memory. This would include the Windows kernel itself and the hardware extraction layer, or the HAL, as well as the system registry HIVE. And last but not least, the boot class device drivers. Now it's important to note that in this stage it does not actually run them, it simply loads them into memory. Next is the kernel loading phase. This is when the system runs the Windows Executive, which consists of the Windows kernel and the hardware extraction layer, which was loaded in the previous phase. And then it will process that registry hive and initializes the drivers and all the services for the operating system. Last but not least is the login phase, and this is very important because the system at this point loads the Service Control Manager and the local security authority. That would be the security settings for the local machine, and then it presents the logon user interface for the user to actually log into the system. Alright, so now that we have kind of outlined those 6 steps, let's talk a little bit about where in the Windows 7 boot process failures occur and what that means to you. So obviously the first step when you have a Windows booting failure is to determine exactly where that startup process is failing. And there are basically 4 distinct groups where you can see those failures. The post segment, the initial startup segment, and when the drivers and the services are being loaded, and last but not least during the logon phase. Now if you have a post failure, that is the BIOS actually running completely through? Typically, if you see a post failure, you're going to be fortunate because the BIOS 9 times out of 10 is going to kick back an error message that's going to enable you to figure out what hardware component is messing up. And so there are a couple ways you could do this. First of all, a lot of times it will tell you on the screen that the hard drive has failed or the primary slave drive has failed. That's a great starting point for you to start figuring out where or what piece of hardware has actually failed on the system. Next, a lot of times you'll see what's called the beep sequence. And the beep sequence is when you first start the computer up, it will give you a series of beeps if something has failed. Based on what that series of beeps is and what brand of computer it is, you can trace back what piece of hardware is creating that beep sequence. Now, during the initial startup phase, typically you will see a non-system disk or disk error. That is indicative of what we call the initial startup failure. Errors before the progress bar to be something along the lines of an incorrect BIOS setting, or a hardware fault, or a missing startup file, or even data corruption on the drive itself, on the operating system. You can try to use recovery tools to fix or replace the hardware component as one course of action here. And a lot of times when you see an issue that's indicative of a missing startup file or data corruption, sometimes you'll see these after a poorly upgraded system, or where the files in the operating system has degraded, potentially due to environmental factors such as magnetic fields or even some sort of malware. Now, in the third instance where you may see an issue is where the driver and service failures occur. The appearance of the progress bar, of course, will indicate that the kernel has loaded successfully into the memory. Here you see a problem often occurring, usually with the issue of a driver or service that's not being able to load properly. This is indicative oftentimes of installing a new piece of hardware, or having a piece of hardware fail, or even having a piece of hardware upgraded and the driver was not installed correctly. Sometimes you can use the last known good configuration or safe mode to get the system running in this instance. And always you can use a device manager help to determine the problem and get the computer running normally. Alright, so the last thing that could fail would be a logon failure. Now, if you find that the user is able to get in and log into the system, but it fails after the user has supplied their logon credentials, 9 times out of 10 this problem is going to be traced back to some sort of program in the startup group. Now, one of the simplest ways to diagnose this, and at least to get into the operating system successfully, is to hold the shift key when logging on to prevent programs from actually loading. And you can use the process of elimination to test these programs. Alright, so you might be asking yourself, well, what recourse do I have when I run into these boot issues? I mean, how can I get into the system to actually do any work, right? So, well, there are some recovery tools that are available to you, and these recovery tools allow you to use alternate boot options. They have a Startup and Recovery Dialog box for you. They have a system configuration tool, boot logging, and of course Windows RE. All these are tools that are available to you to help you get into the system and effect repairs. And we're going to talk a little bit about each of these right now. Alright, so oftentimes just getting the computer to start is half the battle. Once the computer is started, you do have access to significant numbers of configuration tools and troubleshooting tools that will help you resolve the problem. However, if the problem is hardware related, chances are you're going to have to repair that hardware issue before you get into the system to effect any other needed changes. However, if the startup problem occurs after the progress bar appears, you can probably get in the system from a number of different ways. First and foremost, you can suppress the drivers and services. So if you have what you suspect is a driver or service issue, simply by pressing the F8 button repeatedly right after the post completes, you will be able to go into the Advanced Boot Options menu. And that will allow you to choose from a number of different configuration settings. You can either boot into safe mode or last known good configuration. Safe mode basically allows you to boot into the system without loading any of the unnecessary drivers or system calls that otherwise would load. So if you have a bad driver, for instance, that is not a critical component, it may not load in the safe mode, and that will allow you the opportunity to get into the system and effect repairs. The last known good configuration setting uses and goes back, it looks at the last saved configuration setting that actually worked for the boot up sequence, and it will attempt to run that setting. So this is particularly useful after an upgrade or after a new device has been installed. It will go back and it will try to run those old settings. And you can also suppress the startup applications by simply hitting the shift key while logging on and holding it down until the icons appear on the desktop. This will allow all those applications not to run in the background and not to install all those hooks that would normally be needed for the applications. Now, another option that's available to you is modifying the BCD registry file. And you do this through the Startup and Recovery Dialog box. That box allows you to configure the Windows 7 startup process by actually modifying that file. And to open up the Startup and Recovery Dialog box, you would actually have to go into the Control Panel, enter System Recovery System, and then go into the Advanced System Settings. And under the Advanced tab, one of the options should be Startup and Recovery. And you can go into those settings and actually change which operating system will load and some other configurations that will help you get into the system a little easier until you can rectify the problem. Likewise, if you can get into safe mode, you can use the system configuration tool to enable you a great deal of power when it comes to the startup process. Simply by typing start, run, and then type msconfig. Once you've logged in and started using the system configuration tool, there are basically, 5 tabs that are available to you. There's the General tab, which will provide controls that will enable you to perform the normal diagnostic or selective startup sequence. There's the Boot tab, which controls the actual BCD registry settings that enable you to select the operating system and install and configure a limited boot sequence. Additionally, you also have the Services tab that enables you to select the services that will run during the startup sequence. You have the Startup tab, which will enable you to select the startup applications that will run in the startup sequence. And last but not least, the Tools tab will enable you to launch a variety of configuration and troubleshooting tools. So those are the 5 general areas that you can modify using the system configuration tool. Alright, so another option that's available to you is using Windows RE, or the recovery environment. Now, the recovery environment is very similar to Windows PE, but it has recovery tools built into it as well. Now, this will allow you to bypass all the drivers, applications, and services that can be the source of your startup problem. And in order to run Windows RE, it's very simple. You simply have to have the installation DVD, you run it, and you click Repair Your Computer when you're prompted. Using the system recovery tools can also assist you in diagnosing and repairing startup issues. The system recovery tools basically come with 5 sets of utilities: the startup repair, the system restore, the system image recovery, Windows memory diagnostic tool, and the command prompt. Now, the startup repair is an automated troubleshooting tool capable of diagnosing and repairing a variety of problems that can prevent the operating system from starting. Another great feature of the startup repair is that all the activities are logged in a file called srttrail.txt, which is located in the Windows System 32 log files SRT folder. And you can pull that file and you can go through that logging and see if there is an issue. Another tool that's available through SRT is System Restore. Now, System Restore enables you to access the restore points on the computer through a manual or process or an automatic process and use them to restore the system to an earlier state. There's also the System Image Recovery that will enable you to perform a full restoration of your computer using an image you previously created with the Backup and Restore control panel, which we'll talk about shortly. And then there's the Windows Memory Diagnostic. These provide a series of tests for the computer's memory and hardware issues. Then there's the command prompt, of course, and the command prompt will allow you to run a variety of text-based tools that are included with the Windows RE environment. Alright, so this seems like a good stopping point. Now, when we come back, we're going to talk about branch cache, a new feature of Windows 7 that will enable networks with computers at remote locations to conserve bandwidth by storing frequently accessed files on local drives. And we're also going to talk about some other data-related issues, things like backing up and system recovery and things of that nature. So, let's come back for part 4.